Math 2, Unit 11.3. Today we are talking about multiplying binomials. What is a binomial?
Two.
Two terms. Okay? All right. Now, we are on page 653. One way to multiply binomials is by using the distributive property. A lot of people call this method FOIL. Okay, some of you might have heard the word FOIL before. Does that sound familiar?
Foil? Like tinfoil?
Okay. I am not teaching you this. In case you've heard of it, I'm not teaching it to you. If you really want to know about it, I can tell you what it means later. But it doesn't work for every problem, which is why I'm not going to teach it to you. So, I feel one of the best methods for multiplying binomials is to use, and I just call it the box method. I don't really know if it has a name or not. Okay, what do I mean by that? Okay, do you notice that there are two terms here?
Yes.
And how many terms are in the second parenthesis?
3.
Two terms. Terms are separated by pluses and minuses. So right now we have two terms multiplied by two terms. We are going to make a box that is 2 by 2. So I make a square, cut it in half. Do you see how this side is 2 and across the top it's also 2? That's called a 2 by 2 box. Okay? Now, it doesn't matter which one you go with first, but across the top, I'm going to write x minus 6 from my first parenthesis. My second parenthesis is 4x plus 3, and I'm going to write that along the side, 4x and a positive 3. Okay. Again, two terms by two terms. We label one side of the box with one of the parentheses, the other side of the box with the other parentheses. Is that okay with everybody?
Yep.
Now, for each of the boxes inside, we're now going to multiply each of the terms. This is going to make sure that we multiply everything and keep it organized. So do you see right here in this box, it lines up with x and 4x. We multiply that together. What is 4x times x? 4x squared is correct. Now I'm going to go to the next box here to the right. This one lines up with 4x and negative 6. Good. Negative 24x. Going down, this one lines up with the 3 and the x. So 3 times x is 3x. And then we have 3 times negative 6, which is... Okay. What you will notice is that if you have like terms, they line up in the diagonals. So do you see how both of those are plain x terms? So when we write our answer, we write it in descending order. So I'm going to start with writing 4x to the second power, because that has my highest exponent. What is negative 24x and 3x? Good. Negative 21x and then minus 18. And that is my answer. Okay, any questions? Okay. Now, I personally feel like using that box method is the best. I'm going to show you one problem using the distributive property. Okay, are you ready? And then you can decide which one you think is best. You do not have to do my box method. Okay, this is how the distributive property works. M times M is what?
M squared.
M times, and that's a negative 7. M times negative 7 is? Negative 7M. Okay? So I've distributed this M to everything in this parenthesis. Now I need to distribute this 6 through. 6 times m is a positive 6m. And 6 times negative 7 is negative 42. Then you need to find your like terms in the problem. You can see here that these are your like terms. And so we get m squared. Negative 7 and positive 6 makes negative 1m, or you could just put negative m, and then minus 42. What I find with using the distributive property is that a lot of times people forget to go to each of these terms, or they end up trying to multiply the m times the 6 as well, or things like that. When you make your box method, you have to put something in each of the boxes, and it helps you to organize all your information. Now, if you like this better, that's fine. You can use it. You'll just find that I usually multiply it out using the box method. Okay? So, number 2. Give it a try on your own. You can use either method. Okay, so I'm going to write up my box right now. So again, since this is 2 terms by 2 terms, I'm making a 2 by 2 box. If I ended up having 3 terms and 2 terms, I'd make a 3 by 2 box, okay? And so I'm going to label this with 2x and 7 and 3x and negative 4. So when I multiply here, 3x, this box is 3x times 2x, which is, good, 6x squared. This box matches with 3x and 7, which is 21x. Negative 4 and 2x makes, and negative 4 and 7 makes. So we have our like terms here in the middle. And so your answer should be 6x squared. What is 21 minus 8?
13.
A positive 13x minus 28. How many of you got that answer? Nice. Okay, so using a table, this is what they're talking about, what we've been doing this whole time. Okay, so I would like you to go ahead and make your box and find this answer. This time I want you to go ahead and do a box. If you didn't use a box last time, use a box this time. Okay, once you get the answer, check with somebody that you're sitting by. Could I get a volunteer to come up and do this problem on the board? Let's see here. Holly, come on up.
Are you serious?
On the board or on the thing?
On the thing. So, in fact, if we could get, as Holly's writing it, do you want to explain it, Nick?
Yeah.
Okay.
Oh God.
Okay.
That's wrong.
Shut up, Nick.
So you put 3x on one box, and then you put 1 on the other box. You put x on one and then positive 4. Multiply all the terms. 3x squared plus 1x plus 4 plus 12x.
Oh.
Then you can notice that your diagonals are your same terms, and then write them out.
Perfect. Good.
Okay.
Okay. So,
Is that
yeah.
candy?
That was perfect. Now, I had a question out there as I was walking around, and somebody said, could I have put 3x plus 1 here and x plus 4 here. Did anybody do it that way? Where they put 3x plus 1 on the opposite side? Nobody did? What do you think would happen? You'd still get the same answer because you're still going to be multiplying all the same numbers, right? And so it doesn't matter where you put them, but you have to keep the x and the 4 together on one side, and you have to keep the 3x and the 1 on one side and keep them together. So you can't mix up the sides. Like, you can't mix up the parentheses. They have to stay on the same side, but they can go either direction. Am I making sense? Yes?
Yes.
Okay. Any questions? All right. We're going to kind of skip over a few because you guys kind of feel like you get this. Is this a thumbs up, I get it? Or bad? Okay. How do we feel about the table method? If you were making a vote, how many of you like the distributive way better? Okay. And how many of you like the box way better? So we're kind of 50-50. Do I care which method you use? No, not at all. Okay? So you can use either method that you want. All right, I want you to now move on to page 658. Actually, look at 656 first. I don't like I said, I don't like using FOIL. I want to explain to you, though, what FOIL does mean, just so you know, in case somebody asked you about it. FOIL means first, outside, inside, last. Okay, so it's using the first letters of those. Now what they're saying is they're taking your first term and the first term and multiplying it. The first term and the outside and multiplying it together. The insides multiplying together and the last terms multiplying together. The reason why I don't like FOIL is that if you have anything that is not a 2 by 2, it doesn't work. But basically FOIL is talking to you about using the distributive method. Okay? So, but we're going to go ahead and move on now to page 658. Okay, so page 658 here, you have this problem. How many terms are here?
3.
3, and there are 2. If you are using the distributive method, make sure you're taking each term and going to each of these. Each of these terms goes to each of these in here. Okay, if you're using the box method, which size box would you need?
3 by 2.
3 by 2. Okay, so I'm going to go ahead and give you a minute to try this one on your own. Would it matter which side I wrote things on if I have a 3 by 2? Yes, because you definitely want to write the 3 terms on the 3 side, right? Okay, so I'm going to go ahead and make my box here. If you get the answer, raise your hand and I'll come around and check it. Did you? I'm sorry. Okay, I'm sorry I couldn't make it around to everybody. The answer should be 2x to the third minus 9x squared plus 10x minus 3.
Yeah.
Okay. So, who didn't get it? Correct. What method did you use?
Box.
And you didn't get it correct. Okay, let's go through the box method this time then. Okay, so if I write this all out, we have 2x squared, negative 3x, and a positive 1. Make sure you're keeping your signs. And you have x and negative 3. So when we're multiplying, we get 2x to the third, because 2 plus 1 makes 3. This next box, x times negative 3x is negative 3x squared. X times 1 is x. Negative 3 times 2x squared is negative 6x squared. Negative 3 times negative 3x makes a positive 9x. And negative 3 times 1 makes a negative 3. Okay, notice again that your like terms are in your diagonals, but this time you have two different sets of like terms. Do you guys see that? And so we go through here, and we have 2x to the third. Negative 6 and negative 3 makes negative 9x squared. And then 9x and x makes a positive 10x minus 3. Do we see what happened?
Yes.
Okay. Do we have questions? Okay, so on part B it says, how can you use the distributive property to find the product of a trinomial and a binomial? So when you're using those that use the distributive property, what do you need to make sure you do?
Distribute all the terms.
Good. Distribute to all the terms. It's supposed to be 2. Okay, do we have any questions here? All right, so I'd like you on page 658, let's go ahead and do one more like that. Let's do number 9. Again, use either method that you want. And I'll check answers, and I'd like to take a volunteer to do this problem. And maybe the volunteer could do it using distributive property this time. We'll give everyone a minute and it'll be okay. Okay, Chloe's going to come up and do the problem for us. I'm going to go ahead and read my answer since I can't quite make it around. So the answer is 6g to the third plus 11g squared minus 31g plus 14. How many of you guys got it right? Awesome. Good job. Okay. So I'll move it if you... Okay. All right, here goes Chloe. Okay, so Chloe's going to do the distributive method this time. Here's the box. So she's showing how she's taking 2g to each term in the next set of the parentheses and multiplying them. I find that if I'm using the distributive method, that each time I like draw it from one to the next and then write that answer. Draw it from one to the next, write that answer so that I don't forget one. Okay? Which is exactly what Chloe is doing. Now I find that when I'm using the distributive method, actually I'll show you in a second. Let's let Chloe finish.
You're going to say I did the lines to the bottom.
So I like how Chloe, her like terms, she like boxed 2 of her like terms, and she's circled the other one, so it's easy to tell the difference of which one is like and which one isn't. So now she's combining her like terms and she's also writing it in descending order. Super important is that you write these answers in descending order from highest to lowest exponents. That was perfect. Thank you, Chloe. Very good. The only other thing I would say is that, yes, you do. When you're doing the second term, in order to kind of keep it looking nicer, you might want to do your, when you're multiplying it towards the bottom with the second term, but it's no big deal, whatever you guys want to do. Do we have any questions there? Okay, turn to page 659. Okay, so on page 659, I want you to look at number 14. Okay, so right now I'm going to give you a minute. Talk in your groups. How do you find area of a rectangle? What are you going to do here? So I'm listening to answers. How do you find area of a rectangle? Shut up. Okay, how do you find area of a rectangle? Right? So what do you do? Yes.
And the hashtag was
Yes. But now you're going to simplify it. Sorry. Okay, so sharing out. How do you guys find the area of a rectangle? The specific formula. How do you find the area of a rectangle? Base times height or length times width, right? Are you guys with me? So, if they're telling you the length is this and the width is this, what am I going to do? Very good. X plus 5 times x minus 3. Go ahead and multiply that out either using your box method or the distributive property. Okay, so I'll use the box method this time. X and 5 and x and negative 3. What is x times x?
X squared.
X times 5 is?
5x.
5x. Negative 3 times x?
Negative 3x.
And negative 3 times 5 is? Negative 15. So I get x squared. That makes a positive 2x minus 15. That is standard form, highest exponent to lowest exponent. Are there any questions?